What's up YouTube? This is Dennis Panuta for tutorialsEU. In this video we are going to build this game that you see right here. It's called Color Bump and it's a successful mobile game, and you're going to learn basically how to build this game with Unity 3D, which is an amazing tool when developing games and mobile games of course as well. And we are going to use C# as a programming language for that. So if you have no experience in C# or Unity, then you should definitely check out my playlist on that. I have a complete playlist about Unity and C#, so you can find it up here. I think there's a card. If you want to learn more about video game development in general, then of course don't forget to subscribe to this channel and leave a like if you like this video and if you like building video games. All right, before we go any further, let's just test this game. So there we are. I control the ball with my mouse and I can make the ball faster, slower, then I can move around. And once I touch one of those yellow obstacles, the game is over. I can push things aside. But once I touch any of those yellow ones, then I'm done. So let's get through this level, and there we are. So that's it. That's basically what we're gonna build. It's not too complex, but you still need some C# and Unity knowledge, of course, because there are some scripts which we're going to use. We are going to use physics. We're going to use a distance calculator, if you wish, because we need to have the distance that our ball traveled for this bar that you can see right here. Then we also use that as a score. So travel distance is used for the score. And we have this beautiful little trail. We have some effects here, as you can see, and so forth. Even this slow effect is a pretty cool feature, I think. It looks pretty cool. All right, so I'd say as a little motivator, if you check this out, Color Bump 3D has 34,000 reviews. So it probably has a million or multiple million even downloads. And some people like it, some people don't, but that's basically the game that you see here that we're gonna build. It's more or less the same thing, right? Except that we don't have this stage system, we don't have this level system. If you want to learn more about leveling systems, you can of course check out my other videos. For example, the one on Helix Jump, because there I show you how to create a leveling system. There's a complete video, you can find it up here. It's a link up here. It's a 4-hour video about how to build Helix Jump. Quite extensive, but you're gonna learn quite a bit there, of course, as well. So yeah, that's basically what we're gonna build. And as you can see, even this basic little game can make some serious amounts of money, because the thing is, it's always the same. Every single level of those, from a programmatical point of view, is always the same. It doesn't change. The only thing that changes is the level. So what's going to be important is leveling design. But even there, you see, it's just boxes. They have different colors. The ground has different colors. And you're going to learn how to do that. And you can pretty much create your own forms and your own boxes and everything, and then make your own levels. And that's a pretty cool thing. It really is something that is nice to show your friends, and it's just fun to play. And by the way, if you want to really go into depth and want to learn multiple examples, many different examples on how to build video games with C#, including a Minesweeper, Zigzag, Fruit Ninja, Farmville clone, and many more with Unity, then please check out my complete Unity 3D game developer course. Or if you want to learn more about C# first, then of course you can check out my complete C# Masterclass. There I go in depth into C#, how it works. And here you have plenty of game development examples as well, but also WPF, databases, link, and so forth. So if you want to work as a game developer or as a C# developer, my courses will definitely be a great start and will definitely help you get there. All right, so let's get right into developing our game. So you've seen the basics that we have here, everything that we need in order to build the game. And yeah, we pretty much need a ball, we need a map, we need a camera, of course, which follows along with the ball. We need obstacles, we need elements that kill us. So this is an enemy obstacle or a kill and or death obstacle, however you want to call it. Then we have this little effect here then the camera follows along. Yeah, I told that. I think this is a different obstacle, but this is very easy. It's just another form applied to the same rules, or the same rules applied to it. And then we have this slow motion effect. And yeah, that's basically it. I mean, there are some more little tweaks, for example, that the ball cannot fall off the map. It will always stay on this plane. That's something that is also interesting and relevant. But other than that, it's nothing too crazy. So I'd say let's start with creating a new project. So you need to have Unity 3D, but as I said, this is not a complete beginner's introduction to Unity. You should have some basic understanding of Unity. You should have Unity installed, and the version, you can of course use the same version, but even newer versions shouldn't differ too much from what you see here. Now let's create a new project. And this time it's going to be a 3D project, and the project name will be Color Bump Clone. And actually I'm going to call it Color Bump. Let's call it like that. Create a project. By the way, while it's loading, little side info, I bought myself the eraser glasses. They were quite cheap. I paid 200 euros for them. And the Windows Mixed Reality. So I might create something on VR in the future. Please let me know in the comments what you think about VR, if you have VR glasses, because that's, I think, the major reason why there is so little about VR on the internet. So few courses, for example, also few YouTube videos on how to develop for VR, because there's just not too much demand. So that's something that I would like to know. So please let me know about what you think about VR, for example, a VR shooting game or something like that. I could imagine building something like that, but really depends on the demand. So if there are, let's say, 200 likes under a comment which says I want to have a VR video, then I'm gonna definitely create one. I know 200 is a long stretch. It's gonna take a couple of months until we get there, or maybe even longer. But if you are one of those and you really want it, you can of course promote this video, then it's more likely that those 200 will be cracked. Okay, so we have our scene here. So as I said, I expect that you understand the basics of Unity. So you know what a scene is, you know what the main camera, the directional lighting, those kind of things are, that you understand what this transform component does. For example, that it just is the position within the whole world of our game, within a complete scene, that there is some rotation in 3 dimensions here, and then you can scale things up. For example, that this here, this transform, is a component, and then that a game object like the main camera or our player, for example, can have multiple components, such as an audio listener, such as physics, and so forth. Okay, so I'm expecting that you know that. If you don't, please check out my either course or check out my playlist. Okay, so what I'm gonna do is I'm going to change the name of the sample scene straight away. I'm just gonna call it game. So let's call it game. There we are, first change. Make a change, save a change. So I always Control S after I make changes, or not always, but quite often. That's something that I would highly recommend to do as well. Next, what we need to do is to prepare our game for mobile development. So go to File, Build Settings. This thing here should open up, and then add open scenes, because then this game scene that we've just created or renamed should be added. I remove this old selection because we only need this scene/game. And then I change the platform and I change to Android. So here I switch platform, press this button, switch platform. This can then take a little while until it's done, depending on, of course, your hardware and everything. And there we are. So you can see this little Unity icon now has changed, and now it's next to Android. Then we can go to player settings straight away. So press this little button down here, player settings, and let's change the resolution. So in here, resolution and presentation to be precise. So aspect ratio, that's something that we can keep, native aspect ratio. So this depends on the device, but then the default orientation. So I want this to only be portrait. So it should never have a different orientation. That's really important. Okay. Now the next thing that we need to change is the package name. So go to other settings, and in here change the package name to something like .com, then your company name, and then product name. So in my case it would be eu.tutorials. And then this would be flappy, or no, that's color bump clone 1 or something like that. Okay. Then I save it, Control S. Now the next thing is that we need to move the view here, or select the portrait view here. So I have 18:9. You can use 16:9 portrait, that's fine as well. The thing is that nowadays more and more devices have 18:9 as a scale, so that should be fine. 18:9 on a phone, so it's like 2:1 actually. Then the next thing is that we need to create a little plane. So let's create a 3D object here, which is going to be a plane. And this plane here is going to be our ground where our ball slides on. All right. So let's change its values, because currently it has a scale of 111, but we want something like, let's say 75. Okay, now you see it's a long line here going all the way. There we are. And 75 might be a little bit too long. 15 should be fine for now. It really depends on how big you want to make your level, but 15, scale of 15 is good enough. Now let's change the Z position to 75. There we are. Now we of course will need to change our camera, but we'll do that later on. Now this is not our plane, it's our floor. So let's rename our game object from plane to floor. Now we have this plane of 15. Now the next thing is we want to have a ball in here. So let's create a 3D object, which will be a sphere. So the sphere will be our little ball, and let's reset its position here in the transform component. Now you can see the ball is in the center point. So this is 0, 0, 0 where it currently is. Now the ball should be a little up, something like 0.5 up. And now you can see now it's on our plane. Now you could of course change the plane's position as well. You could say, okay, this position should go down 0.5, for example, then the ball or the sphere could be at 0. Okay, so it really depends on how you prefer. Okay, so this, now the ball will be at 0, but the ball is not actually at 0 because the ball's center is at 0. Okay, so the bottom part of the ball is not at 0 because the ball is scale 1, which pretty much means that half of it is going to be 0.5. Okay, so I'm going to go back. I want the floor to be at 0, 0, 0. Okay, so as I said, it's how you prefer it. But in the end, you have to then position everything accordingly. All right, now let's create some materials, because white balls and white grounds is nice and stuff, but it's better to have different material colors. So let's create a new folder called materials. And in this folder, we're going to create a new material. And I'm going to call this one ball, because this is going to be our ball material. And now the ball is already quite good, but I want to make some little changes. And here you can of course change the color. So if you prefer to have a different color for your ball, you could make it, for example, this reddish color, then drag it into your ball, and suddenly your ball will have this color. Okay, so this is really just for you to know how to do it. I'm just gonna leave it as is, but I'm going to create another material in here. So let's create a new material. This will be our floor. And now the floor should have a different color. So I have this grayish color here, 1F, 1F, 1F. This is the color that I'm going to use for my floor. So let's change it in here, hexadecimal value 1F, 1F. So it's just this gray color. It's very dark, so I'm gonna drag it onto my ground. Now here I'm gonna drag the smoothness down to 0. So I don't want to have any smoothness at all. So that's how it's gonna look like. Next, I want to have a nicer little color for my main camera, for the background, because if you click on your main camera, you will see that there is this background here, and I want to not have a skybox as clear flags, but I want to have a solid color. So if you do that, you see that you suddenly have this solid blue color, but I'm just going to use a beautiful magenta color here, E5487B. You can take any color you prefer. All right, so that's that. This is going to be my color. Now, as you saw in the original game, the background color changes and the ground color changes, and also the obstacle color changes level by level. You can of course do that. You can create different colors for every single level. All right, but now you simply know how to change the color. All right, good. Next thing is to change the position of our camera, because currently it's at 1 for Y, and I want it to be at 10, and for Z at 5. And of course, I also need to change the rotation if I change the position. So now if we look at our camera, this is how it looks. So this is how it looks onto our field. Now, of course, we could say, okay, let's move it back a little, but I want to make sure that it doesn't see the edge of our world. And of course, then you need to also move the ball. So I'm going to move the ball in its Y position. You can also, of course, just enter 12 if you're using the exact same values, but otherwise just drag the ball to the position. And here, as you can see, I'm dragging the blue arrow, which only changes the Z value. So I'm changing the Z value of my ball, because if I just drag the ball around, then everything changes. So the Y value changes as well. And depending on the angle, maybe even the X value will change. So just select 0.5, 12. At least that's a good position for now. For me, this is where the ball will be then. And now let's also change the directional light a little bit. Not too much, but I would like to have a different angle. So 60 degrees for the X value and 125 for the Y value. Now you can see that the sun comes from another direction. It doesn't matter where it is, right? So you can put it back to 0. Because it's just directional lighting, it's always going to come from a specific direction. All right, so that's the basic setup of our game. Next, we're going to add physics to our ball. All right, so now let's add some behavior, some movement to our ball. And by the way, I called this ball. Now, the next thing that I want to add is a rigid body. So just search for rigid body and add that to the ball, because this rigid body will simply add physics to the ball. So if I add a rigid body, suddenly it can fall. So it can be influenced by gravity. So use gravity here is ticked. Now it's falling. But anyway, if we don't have a rigid body, so let me remove the component and run it again, you will see that the ball is not moving. Okay, so it's important to add a rigid body. Now we're gonna go back to the 0.5 position for our ball. Next, what I want to do is I want the ball to follow along with my mouse. So when I play around with the mouse, I want the ball to follow along. And let's do that. And let's create a new script for that. So create a folder called scripts, because I want to have all of my scripts in my scripts folder. And let's create a new C# script here. And this one will be the ball controller, because it's going to control the ball. That's the idea behind it. So let's open up this ball controller with Visual Studio. And once we're here, we won't need the start method for now, but what we need is a field, or multiple fields to be precise. One of them is going to be private float thrust. So this is going to be the one influencing the speed of our game, or of our ball. And then the next one is a private rigid body, which I'm going to call RB, standing for rigid body. So this rigid body is just going to take care of physics, right? So of the speed, for example, of our ball and those kind of things. This rigid body is the object which actually controls the position through the physics simulation. So which means that this is going to be the variable which changes the speed, and this is going to be actually applying the speed or applying the physics, okay? So that's the idea behind it. But as I want to be able to change those values in Unity, I want to make them serialized fields. So if I save this now, let's go back to Unity and let's go to our ball. So let's press on the ball. Let's drag the ball controller on here. And you will see that those two fields are not visible here. Now, if I go back and I make them serialized fields, so here in square bracket, serialize field, and I do the same for the rigid body. So I'm gonna save the script, really important, Control S to save the script. Now I go back, and now after a little while, the ball controller will have those two fields. So now you can see I can adjust the thrust to 250, for example, and I can see that there is no rigid body. So it's an empty field. Now I can drag the rigid body onto this field. And that's what I need to do. So I drag the rigid body from the ball onto this position here. Now the ball controller will have a rigid body and can work with something. Okay. Now let's go back to the script because we're far from being done. We need another field, which will be a vector2, and this will be the last mouse position because we need to somehow know where the mouse was in comparison to where it is in order to know in which direction the mouse goes. So vector2 means it's a 2D vector that we're looking at. We don't need the third dimension. So the screen on your phone, for example, is just a 2D screen. It's not a 3D world where you need the third dimension, right? So it's just important where on which X and Y position your finger is in comparison to the X and Y position where it was a frame ago. And based on the difference between those two, you can calculate in which direction your mouse or your finger was going, for example, on the phone. And that will then, of course, apply the force for the to the ball in order to move to the required direction. That's really important. So let's create a vector 2D in here as well, vector 2 delta position, delta pose, which will be for now the vector 2.0 position. So we set it with this value, but we will adjust it later on. Okay, this will calculate the delta position of where the mouse was to where the mouse is, or at least we're gonna store it in this variable. Now, I need to use an if statement because I only want to update or do something if the get mouse button 0 is true. And this is the case if we press on the screen with the left mouse click or if we press on the screen with our finger on the phone, okay? So this will be triggered in both cases. Returns whether the given mouse button is held down. All right. Now the next thing that we need to get is the current mouse position, and that will be the same thing for your finger, okay? So we're talking about mouse, but Unity is smart enough to understand if this is on an Android phone or an iPhone, then it will still be the right calculations or the right code. Okay, so this is going to work on Android as well, so no worries here. So vector2 current mouse position is input dot mouse position. So there is a property here called mouse position, the current mouse position in pixel coordinates. It's a read-only property, and that's exactly what we need. Now we can check if the last mouse position is equal to vector2.0, then just say the last mouse position should be the current mouse position. And we do that because last mouse position, this field that we created here, needs to be initialized at some point, okay? If it's not something that we have actually touched, or if we haven't set the variable anywhere else, we want to set it here to basically say, okay, it should be the current mouse position. So wherever we touch the screen. So if it was not set yet, now let's set it. Then we need the delta position. Delta position is going to be the current mouse position minus the last mouse position. So wherever we are currently, to wherever we were the minute or the frame before, not the minute, but actually the frame before. So we're talking about update is called once per frame. So this void update method here will be called, let's say 30 times a second if we have 30 frames. So we need to store last mouse position outside of this method, because variables that are created within a method are only usable and visible within there and can only be set and reset there. So it's important to have something which is outside, which we can then store for the next turn, for the next update call. Okay, that's why we have this last mouse position field. Now we can set last mouse position to current mouse position. So we calculated the delta position, so the difference between what was before to what it is now, so which position we were at before to which position we are right now. And now we can say, okay, the last position is going to be the new position that we just had. Okay, so we're just moving things one step further, right, for the next frame. So the next frame will know, okay, which position to take. Now we need a vector 3 because we need to apply a force to our ball, and our ball is a 3D or in a 3D world and as a 3D rigid body. That's why we need a 3D vector to apply a certain force to it. So I'm just gonna say force is going to be a new vector 3 delta position dot x, then y, and delta position dot y. Now you might say, why are you giving the delta position y as a z coordinate? Well, that's basically what we need here in order to apply it in the right direction. Okay, so let's use this force that we've just created to apply it to our rigid body. So there is this method called add force, which adds a force to a rigid body. And the rigid body that we're talking about in this case is our ball. So what we're just saying with this line is add some force to the ball. And everything before that we calculated was just to know in which direction the ball should be forced. And this thrust here, this multiplier, is just saying, okay, whichever direction you just calculated here, please add some oomph to it. So some speed, a specific speed. And I'm just gonna say add 150 here. Now let's save this, and actually let's have an else case as well. So if no one touches anything, then last mouse position will just be vector 0 or vector 20, which just means it will just be the center. Okay, so the idea behind this is if you don't touch the screen, you should still just say, okay, last mouse position is going to be a specific position, which is just in the middle of the screen. So if you drag it next time, it will always use the middle of the screen as a basis. All right, so let's go back to our game. We applied the script, we have the rigid body, we have this thrust of 250, and now let's see if our ball is moving at all. So as you can see, I just applied a little force to it and it flew away. Now that's a problem because I don't want the ball to be so super fast. Well, I could of course change the thrust. So let's say I change the thrust to 5. Now let's run it again and apply some force. And as you can see now the ball is moving a lot slower, still pretty fast, but a lot slower. And that is totally fine. That could be okay. But now the thing is that the objects that will be in my way will also have physics applied to them. So they will also have a specific mass that will be heavy. All right, so how can I make one object move another object? By applying some force to it, of course, yes. But the heavier I am, the more easy it will be to push something away. So let's say my object, the ball, is 100 times heavier than, for example, any obstacle, then it will just push it away. That's why I'm just gonna add a mass of 100 to it. Now if we play it again, you will see that the ball is barely moving. We have the same thrust, but the ball is so slowly moving, or it's moving so slowly. So now let's change the thrust to 150 again. And now you can see now the ball is moving a lot better. So now we can move the ball around and the thrust of 150 is good. Now I changed the value to 150, but now after I stop playing, you can see the thrust is back to 5. That's because any change I make to values while in game mode, while in play mode, so while I play the game, will not be stored. They are really just for that particular moment when I'm playing the game. All right, now we have one last thing that we of course need to add to the ball in order for it to be what we need, and that is to not fall down. As you can see now, the ball is falling down, and I don't like that. Of course, I want the ball to stop at the edge. Now there are multiple ways to do that. One is I could add a wall here. So I'm just going to show you real quick. So I could say, okay, let's create a new 3D object, and it should be a quad. So I'm just going to add this quad. I'm going to change its rotation. So I'm going to turn it around a little to 90 degrees for the Y value. Then I'm going to scale it up to 25, 25, 25. Now I have this wall which should be in the way. And now let me drag it to 2, 5. Y 2, 5. So now it's exactly at the edge. And I want it to be convex. Now let's play the game. And as you can see, I cannot go through the wall, but the wall is a little thick as well, and so forth. And I would have to make it invisible, and then all the objects that I'm pushing away are not falling down. So I would have to add tags, and it's possible, but it's a lot of effort. So I'm just going to get rid of this quad, and I'm just going to do it programmatically. So let's go back to our ball controller and add this programmatically. And therefore we need 2 more fields here. Float wall distance, and this is going to be 5, and float min cam distance, and I'm going to set that to 3. And those 2 can be or should be serialized fields as well, because maybe I want to change the values in Unity and test things around. So it's always good to make this possible. And of course, I'm going to make those private because no one else needs those values. And no other class needs those values, and none of them should ever access them. That's why I use private instead of public or something like that. All right, so what I'm going to do is in my late update method, so void late update, I'm going to add a vector3 position, transform.position. So I'm going to take the 3D position of my ball, and I'm going to check, is the position x value less than minus the wall distance? If that's the case, then set the x to minus wall distance. And else if transform.position.x is greater than the wall distance, then set its x value to the wall distance. So I've just wrote a little bit of code, and you might wonder what's happening here. So I'm just checking, is the x position of our ball, and now let's go back here, of our ball, is it at minus, or is it less than minus the wall position? So let's say the wall position is 5, and here you can see 1, 2, 3, 4, 5. So this position here is 5. Now let's actually move our ball to see that. Okay, so I'm going to move it here, and as you can see, its x position is 5. Now if the x position ever is more than 5, then I want it to be 5. The same for minus 5. If the x position is ever less than minus 5, I want it to be 5. And this way, I'm just blocking it from falling down. So that's basically what I'm doing with these lines of code that we just wrote. So let me test this again. Let me move the ball around. Okay, I haven't saved the script. That's always good because this way changes are not applied. So now let's save this. And yes, of course, there's one line missing, and that is to change the position to this actual pose value that we've just calculated. So this vector3 is the position that the ball was. We're just changing its x position, and then we're changing the x position of this vector 3 that we have just created. And then we just say, okay, whatever this vector 3 was, now give it to this transform position. And this transform position is basically just the position of our ball. So it's this component right here at the top right. Here, as you can see, pose X, Y, and Z. Now let's play it again and see if we can fall off. And as you can see, the ball is not falling off anymore. So it's just going to the edges. It's not ever falling off. Then there's one more thing that I want to do. So I want to add constraints to the rotation and to Y. So just open constraints here in your rigid body of the ball and then add those tag boxes, because this will not make our ball rotate anymore, and also it will not jump up. So the X and Z position can still move, but the Y position is never going to move. Okay, so our ball will never jump up or something like that. Okay. All right. Now let's add one last thing to our ball for now, which is that it could not, or it cannot go behind our camera, because that would be a little weird. So for example, now we can go behind the view of our camera. So you can see the ball is gone, and the scene view I can still see it, but in the game view I can't. So let's change that. It's just a two-liner. So let's add that here. If transform dot position dot z is less than the camera dot main dot transform dot position dot z plus the min cam distance. So that's what we had this field for that we just created, or that we created earlier, which just says, okay, the minimum camera distance is 3. Okay, it should never be less than that. So if our z position is less than the camera position's z value plus the minimum cam distance, then do something. And what I want to do here is I want to change the position of z to camera.main.transform.position.z plus the camera distance. So this min cam distance. So it just says, okay, if it's at the bottom of our game scene or game screen, then just put it back there, or don't let it move any further back. Okay. And that will help us to move the ball even though we don't move the ball. So the ball will be moved without the player actively moving the ball. And we also have this late update method, by the way. So I didn't go into why we're using the late update method. And you might wonder, oh, damn, he's using something I've never heard of. So we have this update method, which is called once per frame. The same goes for the late update method. And the late update method is ideal for whatever has to do with the camera and for whatever has to be calculated after movement has been calculated. So in the update method, which is very performant, very quick, we calculate physics. And in the late update method, we just calculate where physics has brought us to where we want the position to be. So let's say physics brought us outside of our field, but we really want to make sure that we're not falling off our screen. That's why we're doing it in the late update, because at that point, everything is already calculated, all the physics. And now we just apply some changes to whatever has happened. And it's called the exact same amount of time. So update is called, and afterwards late update is called. Okay, so that's just why we're using late update here. Right now, let's save it again and see what's happened. And now run the game. Scale it down, and you can see the ball is never going behind the camera. So you cannot go further behind than this. So once we later make the camera, for example, move forward, so the player is forced to move forward, the ball will also move forward and will not go back. All right. So our cube here should at one point be an evil cube or a bad cube, okay? So let's create a new material to distinguish between the bad and the good cube. So we're gonna have a white cube and a yellow cube, or a neon yellow cube. And the yellow cubes are going to be the bad guys, and the white cubes are going to be the good guys. And I don't mean the white guys are gonna be the good guys, but the white cubes, okay? So we're gonna create a new material here. And this is going to be a obstacle death, and color is going to be this color here. So BFFF00. So BFFF0 is the color that I want to use here. Here we are, and now let's drag it onto our cube. So this is going to be the bad guy now. And once we touch him, we want to restart the game. So what I'm going to do is I'm going to give this cube a new tag. So go or press on the cube, go to your inspector on the right hand side, and then create a new tag by clicking add tag. And here I'm just going to call this tag death. So new tag name will be death. Now I press on the cube again and I select death as its tag. Now we can create a new folder, create folder, and call this one prefabs. And let's open this folder and drag the cube in here. So I'm gonna rename this thing. I'm gonna call this one death cube. Okay, so this cube is gonna kill us. That's the idea behind this death cube. And now if we touch this death cube, currently nothing is happening, but what I want to happen is that the game stops. All right, so we need to create the right code for this. So let's go back to our ball controller, and in here we need to add a new call, and this is going to be the on collision enter call. So private void on collision enter, which is called once our object is colliding or the physics body, so which is going to be called once our ball touches anything except for example the ground. Well, it will also be called if it touches the ground, but what I want to happen is it should do something once our enemy is touched. So we need to check if the element that we're touching has this particular tag. So here what we can do is debug log and then collision dot toString. Okay, so toString. Now let's test it and see what happens. And as you can see, debug log object. So we touched an object, and when we're moving, we still have this connection. So we're still connected to the ground, so it doesn't happen multiple times. But now let's move the ball up a little bit, and you will see that it's still being moved, so or that it's touching the ground. So I'm going to clear and let me run it. And yeah, I turned off the Y position, but now you see once the ball touched the ground, you can see that the object, which is in this case our floor, was touched. So our code is working, which is good, but now we want it only to execute something if we touch a death object, so an object which has this tag called death. So what we need to do in here is check if the collision dot GameObject dot tag is equal to death. So if it has this tag called death, and if that's the case, then call the GameManager dot singleton dot end game method. In this case, we use false as a parameter. Why is that? Well, let's have a look what we have here. Bool, it's called win. So if we touched an enemy, we lost, and that's why we have false. If we touched, let's say, the finish line, then we have won, and we would hand over true. Okay, so that's the idea behind this little piece of code. Now there's one little thing that I would like to add right from the start, and that is to check if the game has already ended. So GameManager.singleton.game ended, because if that's the case, then just don't do anything. And this is again to save resources. So we don't want to use any resources that are not required. This if statement would still be called if this method is not available, even though, or if these two lines are not available, even though the game is not running anymore. That's why it's important to have it. Okay, now let's save it. Let's go back, and now let's see if our game is stopped once we run the game. And of course, I moved my ball, so let me move it back to 0.5. Now let's run it again. Okay, and boom. So the game has ended, as you can see here. The game has ended, as you can see here in the console. Currently, our camera is still moving on and still going forward and stuff, even though the game has ended, but we cannot move the ball anymore. It's just moved by the camera, as you can see here. But our idea is that the scene is going to be recalled or restarted 2 seconds after this happened. So when we lose, 2 seconds later, it will just restart the game. So that's what we're going to implement later on, okay? So this is just an example for now. Now let's design our level. And in order to design a level, we need those enemy cubes, and we also need good cubes. So let's create another good cube. In here, let me move it to 0.5 and a little to the side. Now this cube that we had before should be a def cube. Let's rename that. And this is going to be a good cube. Now the good cube, of course, also needs a rigid body so that it can be moved. All right, so now we have those two. And what I also need to change is something in the settings. So let's go to Edit, Snap Settings. And here I have changed it already, move X, Y, and Z to 0.75, because this is a good distance between objects. So usually this is set to 1, 1, and 1, but I prefer to have it at 0.75 for this case, because it's just nicer when the objects have this distance of 0.75, okay? So just as an example, let me show you what this even does. So maybe you have never worked with snap settings. So what you can do is you can move stuff around. You see, it is seemingly moving in the X position. But now if I press the control key at the same time, it's only moving in 0.75 increments. Okay, so it's not moving in 1 increments as the default value is, but in 0.75. Now if I set the position to, let's say, X0 and Z15, this would be a great starting point to snap my element around. So let me snap it to, let's say, this distance here, so the player has enough time to move. Okay, or maybe even further, something like that. Now I can go ahead and create a little map. So let me move it, let's say, here. And this is level design, so you can create your own level now. You don't have to do it as I did. I press Control D in order to duplicate an object, and then I move it 2 elements to the side. Okay, so now the same thing, I duplicate it and move it. Duplicate, move, duplicate, move. Okay, now what I can do is I can get rid of this cube. I can mark those ones, all 4 of them, or you can do it in a hierarchy as well with Shift. And now duplicate, then with Control held, I move them to the side. And as you can see now, we can very quickly create those levels. I'm going to duplicate and move to the side. So let me move it over there. And now once again, like this. All right, now what we can do, of course, with this one as well, position 0 is where I'm going to set it. And then here 15 as a starting point. And now I'm going to create some enemies here. Duplicate, move, duplicate, move. So you can see there is a little distance between those here. So let me activate all those cubes. It's 8 of them. and let's move them one to the side. All right, so now we already have a little map here. Now let's start it and see what happens. You can see now we can move those things, but once we touched one of the bad ones, we cannot move our ball anymore. Okay, so this already works. And now we can very easily adjust our whole map. So what you can now, of course, do is go ahead and let's say you move those here. You move those a little bit to the side like that. Now let's replace this one with two evil ones. And what I'm going to have in between there is actually like this. One that is a lot longer. So let's change its X scale to 7, for example. Okay, now let me move it a little bit. As you can see, now we can very quickly test what we have created here. And we can move stuff away. Okay. And there we are. All right. Now you can, of course, also create evil ones. So let me duplicate this one, move it a little, change its Y scale to, let's say, 5, change its rotation. So rotate it a little bit like that. And then let's add or use those two. Like this. Duplicate them, move them over here, over there, and so forth. Okay. Now, of course, we can not only use cubes and depth cubes, we can also use circles. But in general, once you have so many different objects in your hierarchy, it's always good to create a folder. So create a game object, an empty object, by pressing right click, create empty, and call this one obstacles. And now drag all your cubes into this obstacles folder, because you can now close it down and you can see now it looks a lot tidier and it's a lot better. Now this depth cube that we created at the start is also going to be in there. Now, of course, we can also create spheres or cylinders or whatever you want. Okay, so let's create a sphere, and this one, let's make it or put it at x 0.5 and let's position it at 40.25, or what is it, 40.5. And now let's drag it a little bit, duplicate, drag. Actually, before I duplicate, that's something that is very important, add a rigid body to it. Now we can duplicate it. So let's duplicate this sphere and drag it with Control S, or with Control mouse click, I mean. Now let's take those three, duplicate them, move them, duplicate them, move them again, duplicate, and so forth. All right. Now we can, of course, change this one to be a depth obstacle as well. And now you can, of course, try it yourself. And it's quite easy. We just take a material, we select the object, and we drag obstacle depth into this sphere, or at the bottom here. And of course, we need to tag it with depth. Okay, and there we are. It's that simple. Now you can go ahead and create whatever you want. Of course, those spheres should be obstacles as well. And you can, of course, go to your prefabs folder and drag one of those spheres in there, drag one of those cubes in there, and rename that one to cube, and also drag one of those bad spheres. So this is the depth sphere. Let me rename it to depth sphere. And let's drag this depth sphere in here. I'm gonna drag the original sphere in there. Okay, and there we are. All right, now please go ahead and create your own little map. Feel free to do however you like. As you can see, this one is a quite easy one. You can create quite difficult ones where the user has really to move around and try to avoid stuff. But that's already quite a good start. Now let's test it again and let's see how the game goes. There we are. Let's push everything to the side and cool. Back in the code, we need to add some functionality because so far our ball is constantly just being pushed by either us or by the camera. But the idea is that it's being pushed even though it's not at the edge of the game. So we can simply apply a constant force to it. And let's just do that within the fixed update method. So let's go ahead into our ball controller and create a new fixed update method here, and in here we just say if game manager dot singleton dot game ended, then return. So if the game has ended, don't do anything, but if the game has not ended, so game manager dot singleton dot game started, then go ahead and move the ball forward. So add a move position to it. And we're not adding any force here, we're just moving in the ball. Okay, transform dot position plus vector3 dot forward. So we're just saying push it forward times 5 times time dot delta or fixed delta time. The fixed delta time is something that we need to use in fixed update just to calculate it correctly, so that it's the same speed on all devices. All right, now let's save the script and let's go back to our game. By the way, let's save this game as well. And now let's run it. And let's press on the game. And as you can see now, our ball is being moved. And it's not being forced. As you can see, there's no force. It's just being moved. Let me show you again. The ball, and it's moving. Now it's even moving a little bit forward if it's not doing anything, okay? So I'm not doing anything, still being moved. All right, so that's what we just added, this little fixed update thing where we just moved the position. So the difference really is before we applied a force and now we're just moving forward. So we're just changing its position every frame pretty much. Okay, now we have this little problem. Once we collide with a death part, the game stops. We cannot move anymore, but the game just doesn't work anymore. It's over, right? We cannot do anything and the ball is still moving and stuff like that. So let's add a functionality that restarts our game by just restarting the scene. So let's go to our game manager, and in there we're just gonna add a little line. Let's create a new method here, public void restart game, and it should just call the Unity engine dot scene management dot scene manager dot load scene. Now here we enter 0 because the scene that we want to load is the scene 0. This allows us to simply restart the scene. So now what is a good spot to restart the scene? So to reset it to its initial position? Well, a good point would be, for example, when we end the game. So in here, in the end game method, we end the game, and here we can just check if we haven't won, then just invoke a method. So in here, we're just gonna say, okay, restart the game. Now, of course, we want to restart the game only after, let's say, 2 seconds. So we give the user some time. So we're just gonna say invoke, and this invoke method is gonna call something after a specific time period has passed, and we're gonna call the restart game method. And here it's important that it's typed exactly the same. So it's best if you copy and paste the name of the method. It should be called after 2 seconds. And that's it. So if we didn't win, it should be called. And yeah, I'm using this because we're also adding a multiplier to add the slow motion effect, but we're going to do that in a second. So let's test this first. Let's go back into Unity. Let's start the game. Let's screw up. So run into one of those thingies, and you can see it restarts the scene. So things are flying around, looks pretty cool. And then after 2 seconds, boom, we lost. So if I hit one of those bad guys, let me hit it. Now I cannot move my mouse anymore, but the game also restarts after 2 seconds. So that works already, but now we don't have this cool special slow motion effect. So let's add that effect now. Therefore, we need to go back to the game manager. And in the game manager, let's create a new field, which is going to be a private float slow motion factor with 0.1f. So I'm just going to say it should slow the time down to 10%. So you can change it later on easily if you want to have a different speed here. So I'm going to say this is going to be a serialized field because I want to be able to change it in Unity. That's the idea behind it. All right. Now in my awake method, I'm going to set the time scale. So time dot scale to 1f. So this is the normal time. This is the normal speed. And now I also need to set the fixed delta time because that's the default time step for a fixed update. So in the fixed update method, which we have seen, not in this method, in this class, but in this one here, we're using fixed update. And if we set fixed delta time to 0.02, this is going to be the default time step for a fixed update. Now, in order to actually add the slow motion effect, we go to our endgame method. And in here, we're multiplying the 2 with the slow motion factor. But what we also add in here is time dot time scale is the slow motion factor. And time dot fixed time delta time is going to be 0.02 times time dot time scale. Now this is a little bit mathematic, but in the end what's happening is we're slowing time down, and we do that by changing time dot time scale. So the scale at which the time is passing, this can be used for slow motion effects. That's exactly what we're doing here. Fixed delta time, the interval in seconds at which physics and other fixed frame rate updates like mono behaviors fixed update are performed. Perfect, exactly what we were searching for. Now let's test it with the new settings that we have here. And let's run the game. And as you can see now, time is slowing down. And the effect is pretty cool. Now let me scroll out a little bit and push here and then touch something. As you can see now, things are flying around and it looks pretty cool. I like this effect. Okay, so this is the slow motion effect. It was rather simple, I'd say. As you can see, not too much code involved. We just need to change this time scale, fixed time scale. Now you can of course play around with the value. So if you go to your game manager, now you can see you can change this slow motion factor. So let's say we want to speed things up once we hit one of those enemies. Boom. Now the game is speeded up. Okay, that's the initial value. Let's go back to our game manager. Changed it back, but now let's say we want to scale things up. Now it's shooting through the moon. Okay, great. And as you can see, we restart the scene. So once we restarted the scene, the initial value of 0.1 is set back. Because once we hit an enemy after 2 seconds, it's just resetting the whole thing. And why we had to use this time fixed delta time once again. So let me just go back real quick. Here, multiplied with time scale and so forth. And here, multiplying with the slow motion factor is to make sure that the user doesn't have to wait forever. So let's say we have a 2-second waiting time, which would usually be the case. But now, because we have the slow motion factor of 10 or 0.1, it means that we will need to wait for 20 seconds, but we don't want the user, of course, to wait for 20 seconds. That's why we need to multiply the slow motion factor in here as well. Next, we need to create a little start line and a finish line. So once the user passes through this line, the level starts, and once he passes through the finish line towards the end of the level should finish. Okay, so that's the idea behind it. Now let's create a new folder here, folder texture or textures plural. And here let's create a new sprite, and I'm just gonna say it should be a square, and this will be my line. Now we need to change some things in here. We change to single. So here sprite mode single, pixel per unit 100, then wrap mode clamp, and the filter mode by linear. This just creates a line for us, which we now can use. So let me drag that line in here. Let's apply the unapplied import settings. So I didn't apply those settings. I should have clicked apply, but now they are applied. Now I'm going to call this one start line, and let's see where it is. There it is. And you can barely see it. So here you can see it. This little white dot, you can barely see it. Let's position it at 17 maybe, something like that. And now let's scale it up to 250 in width. And for the Y coordinate, I'm gonna scale it to 4 or maybe even 5, something like that, to 5. Okay, now this is my start line. Now I'm going to duplicate this, and I'm gonna call this one finish line. And now let's drag it all the way up here. So let's say at 55. That's where the level ends, because I have this very basic level, and this is where the level ends. And now my finish line also needs to have a collider, a box collider. So just add a component, enter box, then select this box collider. Because the idea is once the user or the ball passes through this box collider, then the game should be over and the player has won, okay? All right, so now what I'm gonna do is I'm going to create a new script. So let's go to the scripts folder, create a script, and let's call this one goal. And now let's go into the goal script. And in here, we neither need the start nor the update method, so let's get rid of those. But what we need is the onTrigger enter. So once the ball passes through, we want to end the game. So we just want to say GameManager.singleton.endGame equals true. So endGame equal or endGame true means that, let's go back to our game manager, that we won. So that would mean that we have won. So we will need to change the game manager a little bit as well. But that's not going to be enough. What I also need in here is the ball controller. So I need to know if the object that we had the collision with was actually the ball. So we can do that by getting a component and getting the ball controller. There are multiple other ways how we could have done it. We could do it by tags or stuff like that, but using this approach is totally fine. Now what we can check here is if the ball is not empty or the game manager has ended, or the game has ended, so game ended. And if that's the case, then just return. So don't do anything. If it's not the ball that touched it or touched the goal, or if it's not running, so the game is not running, then just don't do anything. But otherwise, end the game. Now this onTrigger enter, if we ever want to use that, the collider that we're using, so this finish line, of course needs to have this isTrigger active. Otherwise, it will not work. So now this is going to be a trigger, and once the ball passes through this on trigger entered method that we have just used here, this one will be called, and then our whole code will be executed. So we don't need to call it manually, it will automatically be called. And what we also can of course do is we can add debug.log goal was touched. And let's save the script and go back to Unity. And then of course we need to apply the script to our finish line. So let's select the finish line, go to project and drag the goal script in here. And now let's test the game. Okay, now let me finish quickly. And we see console goal was touched, game ended. And our game is still running. So now you might wonder, why the heck is the game still running? Well, that has to do with us having in the game manager this line of code here, if not win. So we haven't got the condition that we actually have won. So what if we actually won? Well, then we have this else case in which we just invoke restart game after 2 seconds. That's it. All right, now let's try it again. Let's save the script. Let's run it again and see if the game actually restarts after 2 seconds. If we have won. All right, there we are. So we touched it and we have won. So once we touched this little box collider there, zack, game is won. So now there are, of course, multiple things that we can do for the ball to actually pass through the line, because now the moment it touches it, it's over. But what we can actually do is we can simply move the physics body just a little bit behind it. So here, that's where our line is. But let's actually move the line a little bit to the side, and that's the Z coordinate. Okay, so I'm just gonna say, okay, it's 1 past it, okay, just a little bit behind it, or 0.5 maybe, something like that. Now let's run it again. And let's move the ball to the goal. And now you can see it actually passed through it, and that's when we won. Okay, so this is if you really want to make sure that it still happens, because otherwise, if I go really fast, let's try what happens then. You can see it still goes through it, and only then it will be stopped or slowed down. So it depends on the force, but if you really want to make sure that even if it comes in slowly, it's still gonna pass through it, you can do this little approach. Even though it's really a trick, I personally don't like it, so I'm just gonna go back to Z0. I think the physics body or the trigger should be, if possible, at the same point where the actual visualization of it is. Okay, so next we need to calculate how far the ball has come, and we need to have an indication on how far within the level we are. So in order to get the progress, we need to do several things. Of course, we need to have a visual representation here, but we also need to change our script, our game manager script, to be precise. So I need some more fields. A serialize private transform start transform. Then serialize field private transform end or goal transform. And then finally the private ball controller ball. So why do I need those three? The thing is, I need to know where the start position is, where the end position is, and where the ball is in order to calculate how far the ball is in terms of overall distance. Okay, so if you know where the start is, if you know where the end is, and if you know where the ball is, you can always say how many % the ball has already traveled. And that's why we need to transform only the position of our start line, then of the end line, and the position of the ball. So we just check the ball controller, and then based on that, we can then calculate the actual position. Now we need some more. So public float entire distance, and actually this is going to be a property. So let's go like this, float entire distance, and it will also be private set again. So only this class can set it. Another property, again a float, and this is going to be distance left. So we need to know what the entire distance is and this distance that's left in order to calculate how far we've gone. Then we need to use the start method. So let's create start. So private void start, and here the P for some reason was cut. And in here, I'm just going to say the entire distance is going to be the goal transform dot position dot z minus the start transform dot position dot z. So if we have those two, we can calculate the entire distance. Now we need the update method, and I think we have it here. Okay, so here we need the update method, and in the update method, we are going to calculate how much distance is left. So distance left is going to be a vector 3, which calculates the distance. So there's this method called distance, which takes two parameters. So the first one is going to be ball transform dot position, and the second one is goal transform dot position. Okay, now we know the distance, and we can check if the distance left is less than, is greater than the entire distance, then just set the distance left to entire distance. So let's say we are further away than the start point, then it's just going to say, okay, the distance that is left is going to be the distance between the start point and the end point. So if we look at our ball, the ball currently is behind the start point. So it doesn't make sense to say, okay, the ball has to, or the overall traveling distance is not far enough, because we haven't even started the game. So the actual game really just starts once we pass the start line in terms of the distance calculation, okay? So that's the idea behind this if statement. And then we need another one where we check the position, the z position of the ball, and compare it to the goal transform dot z position. So where's the ball in comparison to the, and if the z position is bigger, then we have passed the goal. And here we just say that the distance left is going to be 0, because otherwise we could go into negative values. So the distance left could be -5 or something like that. And with this, we just say, okay, it should never be negative. So we just say if it is, then we just set it to 0. Okay, now let's save this. We can, of course, debug it. So we could go ahead and use debug log and traveled distance is plus distance left plus entire distance is plus entire distance. And now that I see it, I actually feel like distance left is the wrong term, but it's gonna be fine. Let's just leave it as it is. Let's go back here. Let's create a new canvas, UI, and here I'm just going to use an image. And I'm going to call this one bar progress background. And it should have a specific color, and I'm just going to use a grayish color here. The position should be 0, and here we cannot see it right now, but let me check at the canvas, because the thing is, if you change settings in the canvas, then everything is moving. So we're just saying scale with screen size here for the UI scale mode. And now we can go back here and move around with the value. So if I go to 0, this is our bar. So now I of course need to change the bar a little bit. Let me pull it up. So in here, if you want to do it live and you want to see how it looks like live in the UI, you can zoom out. You could just drag it up here. So something like 420 should be good. Now the width should be more like 500 and the height something like 25. So this is going to be our bar, and maybe we also want some transparency. So I'm just going to add a little bit of transparency. So this is the bar, and now I need another image in there, which is going to be my white image. And this white image here also needs to change its width to 500 and its height to also 25. And now this image, of course, should only fill based on the percentage that we have passed. Now that's going to be a tricky one. You can of course try it yourself. But what we need for this is our texture. So we created this line texture. Now let's go to our image, because our image doesn't have a source image. There's no sprite in here. That's why we don't have a setting of open here, because as soon as we drag it in, you can see we get this new setting here, image type. And now instead of using simple, we're going to use filled. And instead of using radial, I'm going to use horizontal, and the fill is going to be left. And now you can see the fill amount. We can play around with this value, and this is exactly what we want to change. So we want to change this fill amount based on how far the user has come. So I'm going to set it to 0 as the starting point, and I'm going to rename this, by the way. So this thing is called bar progress fill. And I also want to have a little shadow here. So let me add a shadow to this bar, because it's going to look a little better if we have a little shadow here. Okay. All right. Now let's create the code for it. Let's go to scripts, create new C# script. And this one is going to be the game view. So I'm going to call it game view because it takes care of the game view, which doesn't have to do anything with the actual game mechanics. And in the game view, we need to use the update method, but not the start method. So let's create a serialized field in here, because we need to set the image that we want to adjust. So I'm going to use a private image, and here fill bar progress. So I'm going to call it. Now image is not supported here. We need to add the UI namespace. So Unity engine.ui. In this namespace, the image class is included, and that's why we need to add it if we want to use image. Now we can play around with images in our code. We need another field here, private float last value. And now in the update method, we need to add, first of all, the check if the game is even running. So if the game manager.singleton.game started is false, so if the game hasn't started, then just return. Don't do anything. But otherwise, go ahead and get the travel distance. Traveled is equal to game manager.singleton.entire distance. Now you see why it makes sense to have this entire distance to be a property which we can access. This really makes our life a lot easier. Singleton.distance left. So it's just going to calculate now what is the travel distance, so how far have we come, and then it's going to calculate a value based on this travel distance divided by the entire distance. So it's going to look how many percent have we covered already, or have we passed already. Entire distance. And now we can check if the game manager.singleton.game ended and value is less than last value. If those are true, then just return. Which pretty much means don't let the progress bar move backwards after the game ended. We don't want the game to just go backwards. Okay, that's what this line prevents. And now we can go ahead and change the fill amount of our fill progress bar. And we're going to use a math f lerp here. So what lerp does is it linearly interpolates between a, b, and b by t. So we're just gonna use fill bar progress dot fill amount with a value, well then with 5 times time dot delta time. And finally, our last value is going to be value. Okay, so a lot of stuff that's happening here, a lot of code. I didn't go too much into this one here. If you want to learn more about lerp, you can check out the documentation and also on what interpolation is. But it's pretty much just saying, okay, whatever amount we have already passed, that's how much you should display on the screen. And you will see what that means in a second. So we have this game view now, and let's add this game view to our canvas. So let's press the canvas and drag the game view in there. Now you can see we need this fill bar progress. And this fill bar progress is our bar progress fill image. So I'm going to drag that in here. So what this whole piece of code simply should do, it should change this fill amount here, which changes here this fill amount, as you can see. So that's the whole fill bar progress fill amount code that we had here. This line. All right. Now if we start the game, we should get an error because object reference not set to an instance, as you can see here. So the bar is not filling up. We can of course check the error, and we will see that our game manager is not getting some values that he needs. So he doesn't know what the position is and so forth. If you have that, then it's easiest to just check out the game manager, and then you will notice that we haven't started to, well, we have no start transform, goal transform, and ball. Now that's quite simply fixed because the start line is our start transform, the finish line is our goal transform, and the ball is our ball. So if we drag all of those in there and we run it again, this error should disappear. And as you can see now, this bar is filling up based on how far we have traveled. And there we are. So we passed through our goal and that's done. All right. Now you might say that once we start the game and once we push our ball, we have this little problem because as you can see now, our ball is cool and stuff, but as soon as we touched many balls, we don't know which ball is the one that we are playing with. Of course, you could say the one that is moving forward and so forth, but the easiest way to fix this is to give our ball a trail renderer and some effects. So let's go on the ball and add this trail renderer component. So what I want to have here is to add a material. By the way, this ball needs a material. So let's go back to our materials. I'm going to create a new material here. And this one is going to be the ball trail. And this ball trail should not have a standard shader, but in here it should actually be a particle and here a standard unit. So once you select that, as you can see, things look a lot different. We can change from opaque to transparent here. And now we can drag this ball trail to our ball. Now let me make the mesh renderer smaller and everything so we can see it a little better. So here's the trail renderer, and the trail renderer needs, within materials here, it needs an element 0 where you can see there's no material. So let's drag this ball trail on there. And now we should be able to see an actual trail following our ball. Now I want to change the time, but let me do that afterwards in a second. So let's just test it. Let's see if we see anything. So you can see there is this white trail which follows along, and it follows along for 5 seconds, which is quite a long time. So this is this timer that you have here. So let's put it to 0.5. That should already look a lot better. So let's run it again. As you can see now, it's just this little trail which follows along. And if we move fast, then the trail will be longer. If we move slowly, the trail will be shorter. Okay. Now, the next thing that we need to change is its width, because now currently it has half of the width of the whole ball. Now I set it back to 1. So let's play it, and you will see it's this wide, huge thing. If you want that, that's good. This might be the effect that you want, but I prefer to have a cone kind of look. So I'm gonna go down to, let's say 0.25, 0.3, and on the right side here, I'm going to add a key. So I'm gonna drag this key down, and now you can see that the whole thing has this slightly different graphic. So let's run it again just to see what's going to happen. As you can see, now we have this little cone. So I prefer that. Now, of course, we want to change the color. At least I want to change the color. Maybe you don't. So this is the color that I would like to have. 09CED7. I'm just going to copy this color. You can copy it as well. And then I'm going to enter the color here. There we are. But then here I'm going to add some alpha, and here as well I'm just going to go full alpha mode. And now let's test it again. Let's see how it looks with this new alpha, and as you can see, it looks a lot better. Okay, so that's how easy it was, and you even have this little alpha, and I think it looks a lot better than what we've seen before. Now corner vertices is going to make it look a little different even. So you can see now it looks quite good. And then here, if you hover over it, if you want to know more how many vertices to add for each corner. So I'm just going to add some more vertices at the end here as well. And I think we can leave the rest as default. We can just test that again. It's not much that you change here, but those little changes can really make an impact onto your game and onto how it feels, okay? Okay, so this is the trail. That's a trail renderer, but I also would like to have some particles there, some particle effects. So let's add particles to our game. And we do that by adding particle effects. So I'm going to add a particle system onto the ball, effects particle system. As you can see now, it emits particles all the time. So if we start the game now, it's going to emit those particles all the time. But now I don't want the particles to go up all the time. I want the particles to actually go in a certain direction. They should go backwards. And I also want to change the lifetime. So the start lifetime is 5 seconds, but I want it to be a random value between, let's say, 0.5 and 0.25. So what you can do is you can press this little button here at the right hand side. It's very small, but you can press it and change to random between 2 constants. So I'm just going to say 0.5 and 0.25. Then the same with the speed between 2 constants. So here I would like to go from 0.5 to 5. And then also the size should also be a random. So I would like to have a random value between 0.1 and 0.2, because I think that the particles are way too big. They're way too visual. All right. So I would like to put them a little down. Let's go back and test it. And as you can see, the particles look a lot smaller. Okay. That's already good. Now let's change the color. And the color that I would like to use is 00F7FF. So I'm gonna drag it in here. And let me run it again. And as you can see, that's already quite a step forward. And now an important change that we need to do is in emissions. So in emission, there's this rate over time. And I don't want to have rate over time. I don't want to emit based on time. I want to emit based on distance traveled. So rate over distance is what I need. So I'm just going to say 50 because I want to have loads of particles, but only based on distance traveled. So if I change that and I move the ball, now you see that it creates those particles. And there are many of them, okay? And this actually changes the performance. So here you need to play around with the values because this really has an impact on performance. Now on shape, you can change the angle. So for example, currently the angle is 25. I want the angle to be 0. And also I want to change the position, the rotation here actually. So here I want to have a 180 degree X rotation. It's a little small here. Now you can see. So 180 X rotation, and the position should be not inside of the ball, but let's say a little bit behind the ball. So minus 0.5 should be a good value. And I want to scale everything up by 0.5. So this is something that you really can just play around with, okay? You can play around with the shape, you can play around with pretty much everything that you see here. But now let's test it again. And you see now the particles follow our ball, or they are at least behind the ball. So the next thing I'm gonna change is color over time. So here, let me add some changes. I want to have different color over lifetime. So it shouldn't be always white. Towards the end, it should be transparent. So I'm just gonna say towards the end, be transparent, like that. Now let's see again. And as you can see, it looks a lot better because over time they become transparent. So they don't just disappear, but they disappear in an over time manner. And then I would like to have some noise. So let's create some noise in here. And I'm gonna put the strength down a little bit to 0.1. I don't want to have huge noise, but just a little bit of noise. And now let's run it again. And it's really minute changes, very little difference, but that's how it is, right? Okay, that wasn't it. I also wanted to add something else. So let me see. All right, the renderer is turned on, and in the renderer, and then there's one very important change. So something that I personally don't like when we test this. So as you can see, the trail always goes the same direction, or not the trail, but the particle effect. And this doesn't look very good. So we can change the simulation space to world, and that will change that. So let me show you. Now, as you can see, now the trail follows, but also the particle effect. So the particle effect looks a lot better now. All right, so that's it. You can see that's how you can basically build the game. Now let's save the game. So pause the game, save the scene, save the whole project, and now you have your own little game. Alrighty, so I hope you enjoyed this video. I hope you enjoyed this little tutorial where you built this game along. I hope you also built this game along and didn't just watch. Probably you didn't just watch, because that would be boring, right? So if you did like this video, then please leave a like and don't forget to subscribe, because there's a lot more of this stuff coming up in the future. And yeah, I know this is a long video, so probably only 5% or even 3% of the ones who started it have actually finished it. So if you did, congratulations, good job, you've done it. You looked through the whole video and you probably also built the game, so that's a cool thing. If you managed to build your own game and you publish it, and I think after going through my tutorials you should be able to do so, then please let me know about any game that you've published. I could even make a little review on YouTube, so this could be a great story. It could push your game a little more, a little further. So if you do that, if you're successful with the game, or if you just started off with the game, please let me know. I would very much appreciate it. And yeah, if you want to learn more, then please consider buying my whole course. I spent a lot of time to create a great course. You know my teaching style now, and this is a lot more, let's say, fair, or a lot easier style, or more chilling style, let's say. than the one in my courses. There I'm a little more precise and strict, let's say, but this is more of a YouTube setting for me, and I really like this kind of style. I really like to create these videos and also to teach you guys how to create these cool little games. And yeah, thanks a lot. And yeah, leave a comment, of course, if you have any feedback or any ideas for the future. And of course, don't forget, I bought a VR or a VR glass here, or glasses. So if you want VR, let me know as well. Leave a comment and like other comments if you agree. All right, so hopefully I see you in one of my next videos. I'm Dennis Panuta for tutorialsEU, and have a nice day.